Guys, welcome back to TechDose, and in this video we will look at find if array can be sorted problem, which is from Leetcode number 3011. We will look at two approaches, and the last one will be the most optimal approach. Let's now read the problem statement. In this problem, you are given a zero indexed array of positive integers nums. In one operation, you can swap two adjacent elements if they have the same number of set bits. You are allowed to do this operation any number of times, including 0 times. Return true if you can sort the array, otherwise we need to return false. Let's look at the constraint before looking at the example. In this case, the num's length is 100 and each of the item is less than equals to 2 to the power 8. So all the items is maximum of 9 bits and you have just 100 items, so you can even write a brute force algorithm and get it accepted. Now let's see an example for better understanding. In this problem, we are given an array and our goal is to determine if we can sort this array in ascending order based on two given constraints. If we can sort it, then we have to return true, otherwise we need to return false. The two constraints are, the first one being only adjacent numbers can be swapped, and the second constraint is only when they have the same count of set bits you can do the swapping between the adjacent items. Okay, so if the two items are not adjacent, you cannot swap, and even if two items are adjacent, they have to have the same number of count of set bits, right? So if we look at this given example 8, 4, 2, 30, 15, then can we sort it in ascending order? Well, if you look at the state on the right hand side, then I can actually swap these 2 with 4 and 15 with 30, because 2 and 4 have 1 set bit and 15 and 30 has 4 set bits. Now after the swap, you will get to the second state. In this case, you can swap this 2 with 8 because they both have 1 set bit, and then you get to the third state where you can actually swap 4 with 8 because they are adjacent and they have just 1 set bit. After this, we go to a state where everything is sorted in ascending order. So it means that the given array is sortable under the given two constraints, that only adjacent items with the exact same number of set bits are swappable. Before looking at the solution, we need to learn about the optimal way to count the number of set bits. So in this case, if the given number is, let's say, 10 in decimal, then in binary it will be 1010. In order to find the number of set bits, we need to use the technique of ANDing n with n minus 1. When you AND n with n minus 1, then effectively you are removing the least significant set bit. Okay, so let's do this. If you AND n with n minus 1, then you are effectively removing the least significant set bit here, and you get 1000. Again, if you make it the new n and find out n minus 1 and do a bitwise AND between them, then you are effectively removing the least significant set bit. So one by one, if you remove the least significant set bits, then the number of steps it takes to convert n to a value 0 is actually the number of set bits, right? And this is the code here. You can keep a count equals to 0 and you can run a while loop until your n value becomes 0, and you can continue to AND n with n minus 1 and reassign it to as a new n value and continue to count the number of steps you took. So in every step, you are removing the least significant set bit, and then finally we return the count of set bits. This is how we can count the number of set bit. In the worst case, you know that the number of set bits will be all the bits. And what are the number of bits in a given number? In decimal, it is log n base 2. So the time complexity will be log n base 2. In C++, there is a built-in library where you can write _built-in _ pop count of n will return what is the number of set bit, and this is also the same algorithm which is based on order of log n, right? You can check for library in your own languages, otherwise you can implement this piece of code. Now let's look at the first approach, which is based on the suboptimal bubble sort algorithm. Why did I choose bubble sort and why not any other sort? Because bubble sort is a sorting algorithm based on adjacent comparison and adjacent swapping of elements, right? And that is the requirement of the problem. And that is why we went with bubble sort instead of any other sorting algorithm. So let's take two examples and we will see how the bubble sort helps us in solving this problem. Now according to the problem, what we will do is we will be starting with the first item, and what bubble sort will do for ascending order sorting is it will push the largest item at the end. So in bubble sort, we will be comparing 4 with 2. If they are in correct order, we don't do anything. If they are not in correct order, then we will be doing the swap. Now 4 and 2, are they in correct order? No, and we need to swap them. But swapping is possible if they are adjacent. Definitely in bubble sort, two items will always be adjacent because we always do adjacent comparison. And then the second thing that we note is the count of set bit. What is the count of set bit in 4? 1. Count of set bit in 2? 1. 4 is 100 and 2 is 10, right? They both have one set bit count, and that is why we can do the swap and we can move this 2 and 4 here. Now we will move to the next item, which is 4. Compare this 4 with 13. Are they in correct order, ascending order? Yes. So don't do anything. Compare this 13 with 7. Okay, they are not in correct order. They need to be swapped. So if you want to swap, they have to have the same count of set bit. The count of set bit in 13 is 3, which is 1101, and the count of set bit in 7 is 111, which is again 3, right? So yes, you can do the swap. So when you do the swap, you can move this 7 and 13 here. Now the largest item has been pushed to the end. Again, we will repeat the process. We will start with 2 and compare it with 4. So no swapping is required. Compare this 4 with 7, no swapping is required, and you are done. When in a process there is no swapping required, you are done, right? Definitely we were able to sort the given input array, and therefore we will return a true here, saying that it is possible to sort the given array in ascending order under the two given constraint, that adjacent swapping will be done, and adjacent items for them to be swapped must be having the same count of set bit. Now if you look at the second example, here I will be trying to do the bubble sort. Again I will start at this 3. I will compare 3 with 4. Are they in correct order? Yes. We will compare this 4 with 2. Are they in correct order? No. So they need to be swapped. But before swapping, we need to check the count of set bit. They have one set bit. So we can swap this with 2 and 4, and we are done. In the next iteration, we will compare this 3 with 2. And when you compare this 3 with 2, are they in correct order? No. Then the second thing is, do they have the same count of set bit? No. This 3 has 2 count of set bit, and this 2 has 1 count of set bit. That means we needed to swap them, but they could not be swapped because they had different count of set bit. And so they are not sortable, and you can return false immediately without having to check anything else. Now if you need more intuition into why this will work, then I will explain this in just a while, so stay tuned. So the idea of this entire solution is, if the swap is required but we cannot swap, then we need to return false, saying that the array cannot be sorted. Otherwise, if the entire bubble sort algorithm can run without having to see that a swap is required and you cannot swap them, then we will return true, as we saw in the first example, right? The time complexity will be order of n square for the bubble sort, and every time you are comparing one item with the adjacent item, maybe you will require to swap them. And so for finding the set bits for each of the item, it will be log n, right, for each of the numbers. And that is why the time complexity will be n square log n, and the space complexity will be order of 1. This is the bubble sort solution, where I am given the nums array, and I will be applying the 2 loops of bubble sort. Now for every adjacent comparison, I will be checking if they are in order, in ascending order, then we will just continue to the next pair. Otherwise, if they are not in order and they need a swap, then I will be checking if they have equal count of set bits by using the built-in pop counter. If they have the equal count of set bit, then we will be doing the swap. Otherwise, if swap is required but we cannot do the swap because the number of set bits are different, then I will be returning a false, saying that it is not sortable. And if after having checked all the possible pairs and swaps, if we can sort the array, then we will return true. That means the array is sortable. Now let's look at some observation which will help us build the optimal solution. The first point here is, the numbers with the same count of set bits can be assumed to group together. If you look at the array given, and if I want to divide this array into groups, where each group will be a sub array, where all the items in that sub array will have the equal count of set bits, then this entire array will be divided into 4 different groups. The first group here has 4 to 8 with 1 count of set bit. Second group has 3 count of set bit containing 13, 7 and 14, and so on. You will find the third group with 1 count of set bit, and the fourth group with 3 count of set bit. The second point to note is, the swap is only possible in a group. It cannot be done across the group. We can try to do swapping between 2 and 4, it is possible, but swapping between something like 8 and 7 will not be possible, because the only adjacent swapping are allowed. And even if 7 has to come adjacent to it, but still they have to have the same count of set bit. And if they had same count of set bit, then they must have been in the same group. Why will they be in different group, right? So if they are in different group, it means they do not have same count of set bit, and hence they cannot be swapped. Even if same count of set bit groups are present, but separated, then they cannot be swapped to with any of the item, because only adjacent swaps are required, right? So in between there must be a group with different count of set bit. Therefore you can observe that swapping can only be done within a group and cannot be done across the groups, cannot be done with different group items. Okay, so this leads to our third point, that if you want to sort in ascending order, then if you compare this first group with the second group, then the maximum of the first group must be less than equals to the minimum of the second group. Otherwise, how will you make it ascending order? And this should be true for all the adjacent group. That means the maximum of the second group must be less than equals to minimum of the third group, and the maximum of the third group must be less than equals to the minimum of the fourth group. If any one of the adjacent group are not following this rule, this means that ascending order sorting will not be possible, right? Now let's consider only the first two groups. Okay, and let's consider this array from index 0 to index 5. We have 6 elements. Now in this case, if I have to find whether the sorting of these items in ascending order is possible with the given constraint of adjacent swapping with same count of set bit, now we can swap all these numbers 4 to 8 in whatever order we want. We can arrange them in ascending order. We can arrange the second group also in ascending order, but we cannot take one item from the first group and swap it with any item of the second group. That is never possible. That means if I can find an item from the first group which is larger than any item of the second group, then it cannot be sorted in ascending order. And according to greedy approach, you can just take the maximum of the first group and the minimum of the adjacent group and just match it. If the maximum of the first group is less than equals to the minimum of the second group, then it will always be possible to sort these two groups in ascending order under the given constraint. Okay, in this case it is not possible, but let's assume that you did not have this 8. Then will it be possible? Yes, because you can arrange this 2 and 4 and make it 2, 4, and you can arrange this 13, 7 and 14 by doing a swap, and you can make it 7, 13 and 14. So yes, it is ascending order, right? So we will make use of these 3 observations and try to build an optimal solution which is based on the sortable segments check. Now again I will be explaining you 2 different examples. In the first example, let's assume that we have 4, 2, 13, 7, 14. What I will be trying to maintain is what was the maximum of the previous segment, and in the current segment what is the maximum and what is the minimum of the current segment. Fine. And for any segment I will be maintaining what is the count of set bits, so that I will know what all items are grouping together to form a segment, right? So in this case, if I start with the first item 4, then I will be assigning previous segment maximum equals to minus infinity, because there is no previous segment. Current segment maximum will be the first item, and minimum will also be the first item. If you have just one item, that is the maximum and minimum. What is the count of set bit? It is 1 year, right? Now we will always start processing from the second item in a segment, so that is 2. Now when 2 comes in, then we will check if it belongs to the same grouping, that means the same segment. So the count of set bits in 2 is 1, so definitely it will belong to the same segment. Now I will try to maximize the value of max, and I will try to minimize the value of min. So the max is 4 greater or 2 greater? 4 is greater, so no change will happen here. Minimum 4 is smaller or 2 is smaller? So 2 is smaller, so this will get updated to 2. Okay, now we will go to the next item. When we go to the next item, again it will be repeating the process, and I will find that this has a different number of set bits. It will have 3 number of set bits. Okay, so this will not belong to the previous segment. When this happens, then always I will be checking if the previous segment maximum is somehow greater than the current segment maximum. As I had explained, if this is true, then the array will not be sortable, but minus infinity is not greater than 4, so it is fine till now. Okay, and now we will be starting a new segment because the previous segment has ended. So the current segment maximum will get assigned to the previous segment's value, and this will become 4. Because if we jump to the new group, then the current group will become the previous group, and in the previous group whatever is maximum will be contained in the previous segment maximum, so that will be 4. In the current segment maximum we will assign it with 13 initially, and the minimum will also be assigned with 13, and the count of set bits will be reassigned with the count of the first item of the segment, which is 3. Okay, now we will start the processing from the next item again. Now for 7, what is the count of set bit? Again 3. So this belongs to the same group, so I will be updating the maximum 13 is already larger than 7, so no update, but minimum will get updated to 7 because 7 is smaller than 13. Okay, we will go to the next item, which is 14. Now 14 is also having 3 set bits, and so this belongs to the same group or segment. Therefore, the maximum will get updated to 14 and the minimum will remain the same as 7 because 7 is smaller than 14. Now when we go to the next item, we have run out of bounds. So we are done with all the items. Now when we are done with the current group, again we will compare the minimum of the current group with the maximum of the previous group. If the maximum of previous group was somehow larger than the minimum of the current group, then it will not be sortable. But we could not find this condition true for any of the adjacent segments, so we will return true here that this is sortable in ascending order, right? Now let's try this with another example, example number 2. In this case, I will take the first item, that means 0th item, and as I will assign the current segment maximum with 8 and the minimum with 8 as well, and I will find out the count of set bits here, which is 1. Okay, and the previous segment maximum will start with minus infinity because there is no previous segment. So I will start processing from the first index, which is 2. Find out the count of set bit, it will be 1. It is the same as the current group count of set bit, so it will belong to the same group. I will update the maximum, max of 8 comma 2, it will be 8, minimum of 8 comma 2, it will be 2. Okay, now go to the next item, 4. Again 4 has one count of set bit, so it will belong to the same group. Therefore you will update the maximum as max of 8 comma 4, minimum with minimum of 2 comma 4, so no update. When we go to the next item, then the count of set bit here will be 3. Now this is not equals to the set bit count of the current group. Therefore we have moved to a new group. Now when we move to the new group, then we will always check the previous segment maximum with the current segment minimum. If the previous segment maximum happen to be greater than the current segment minimum, then array will not be sortable. But this is not true in this case, so it is fine. And I will assign the previous segment maximum equals to 8, and the current segment maximum will be 13 and minimum will also be 13. We will also be setting the set bit counter to 3, okay, which is the count of set bit for the current group. We will go to the next item, which is 7. Find out the count of set bit, it is 3. Now this 3 is equals to the current group count of set bit, so it will belong to the same group. Update the maximum to max of 13 comma 7, update the minimum to minimum of 13 comma 7, so this will become 7. Now when we go to the next item, we are actually out of bound. Now in this case, the previous segment maximum is actually larger than the current segment minimum. This means that the array will not be sortable and we have to return a false here. Okay, so this is how this entire approach is working based on the sortable segments. Now the time complexity of this is we are iterating through each of the item exactly once, and whenever we go to an item, we are finding the count of set bits, which is log n. Therefore the time complexity will be n log n and the space complexity will be order of 1. Let us now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, we are given the nums array. I am finding the number of items in the nums array, and then these are the variables which are defined as I had explained in the dry run. I will always be starting with the second item, which is index 1, and I will be processing until we run out of all the items. Now this is the extraction code where I will be checking for all the items which belong to the current group. So I'll be extracting the current segment, and I will always keep on updating the max and minimum, right? And when I am done with the current group, then when I move to the next group, I have to always check that the previous segment maximum, if it turns out to be greater than the current segment minimum, then the array will not be sortable, and so we will be returning false. Otherwise, if we have not reached the end of array, then I will be doing the reassignment of the previous segment maximum with the current segment maximum, and the current segment will move to the new segment where the first item will be assigned as minimum and maximum, and the count of set bits will also be updated with the first item of the group. Now after having processed all the groups, if we could not find any case where previous segment maximum was greater than the current segment minimum, then I will be returning true, saying that the array will be sortable. So I hope you were able to understand this. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.